Everyone, please give an initial welcome to our next speaker, Oskar. Woohoo! All right, and while Oskar is getting situated, are you ready to hear from Oskar?
All right. Okay, hello Berlin. So today I want to take you on a journey and share the story of how did we bring React Native to Apple Vision Pro, which at the time was an unreleased platform with many unknowns. Additionally, we did all of this without actually having a device. And of course, we requested to get the developer kit from Apple, but unfortunately we never got it. But even that didn't stop us from making this happen. So my name is Oskar, and I'm a React Native developer at Callstack, and I'm currently working in the R&D team on React Native Vision OS. And I'm also a React Native core contributor and an open source maintainer. So let's start with a question. Who tried Apple Vision Pro before? Okay, we got a few people, cool. So let's begin the story from the day we watched Apple review their new device. So the conference took place in June 2023, where they showed our new macOS and iOS updates. But then, at the end, they said this well-known sentence, that they have one more thing to show, and that thing was an Apple Vision Pro, which got reviewed after almost 9 years without having a new device. And the keynote showcased what everyone thought the future looked like. We've got huge flying windows that you can control using your eyes and hands. And immediately we started to wonder, how can we build apps for this platform with React? And we envisioned a world where you could port all of those awesome React Native apps, execute a few commands, and have your app running natively on this new platform. And to create cross-platform applications until now, you would need something like Unity combined with C#. And Unity is great for building games, but it's not so good for creating spatial apps. Additionally, you need to pay for Unity. So that's something to keep in mind. So who used Unity before? Raise your hand if you did. Okay, great. But in contrast to Unity, React is a universal app building language. And thanks to React Native, it allows you to ship your code to 10+ platforms. So adding XR devices to the list makes a lot of sense. So our goal is to make spatial apps easy to build for any device. And that's what React is all about with their Learn Once, Write Anywhere slogan. So now let's discuss some already available out-of-chip platforms. So React Native is capable of shipping to iOS and Android by default, but thanks to awesome open source projects called out-of-chip platforms, we are able to extend its capabilities to additional platforms. So we've got React Native macOS, we've got React Native tvOS, which should be renamed React Native TV because it can ship to React Native to tvOS and Android TV. We've got React Native Windows, React Native Web, and React Native Skia, which uses the Skia as the renderer, and it currently supports Linux and macOS. And now this family is joined by React Native Vision OS. And everything we've been working on is available as open source software. So you can check out our GitHub and take a look at the codebase yourself. So let's take a quick look at the new operating system called Vision OS, which thankfully is based on top of iOS, which made our job a lot easier. So let's start with this. Spatial apps are different. We don't have a mouse, keyboard, and what we have is hand and eye tracking. We are not sitting in front of a screen, but we are immersed in a real, by screens in a real surroundings. And we can render our content everywhere using immersive spaces. So Apple Vision allows us to display our content in 3 main ways. We have normal windows, and we have volumes, which allow people to view 3D elements from any angle. And the third option is the immersive spaces, which allows you to render your content around the user. And as you can see on the video, the user can change the spectrum of immersion. So they can set it to, for example, to 50% if they want to. And apps need an explicit user permission to enter into this immersive mode each time. And with the release of the new operating system, Apple is pushing their new way of building apps, which is SwiftUI. And this is an important detail because React Native is not using SwiftUI as of today, so we needed to do some refactoring. Last but not least, we've got ornaments, which allows us to present controls and information related to a window. And recently, Apple introduced visionOS 2.0, which unlocks many new great APIs for developers. And now we get access to the camera feed, and we can process each frame buffer to react to what user is seeing. And this has to be probably one of the most requested features by developers. So now let's talk about how we actually did it. So bringing React Native to visionOS was full of unknowns. We experimented with something until it finally started to work. So in June, the visionOS Developer SDK has been released, and we started to investigate if bringing React Native to this platform is even possible. So as it turns out, there are two ways Apple Vision can run apps. On the left side, you can see the native mode, and on the right side, you can see the compatibility mode. So compatibility mode has some limitations. For example, resizing increases text, background is not translucent, and the app generally feels flat. And on the right, you can see we've got the UI elements from iPhone. So for example, the alert component comes from an iPhone, but on the left, the components are styled to fit visionOS. And on top of that, we also can't leverage any of the visionOS APIs that I've just talked about. So skipping ahead to the release of the device, users want native apps. And there were even blog posts listing all of the native apps that you can download right now because they were just so much better. And in the developer SDK, we also got the simulator, which is a bit different than what you already know, because we are actually standing in a room and kind of wearing the headset. We can look around using our mouse, click on stuff, and even change the rooms we are in. So for example, now I'm in the kitchen, and now there is a living room. And Apple did a great job on the simulator for 2D apps, but for 3D, I will get back to this later. So who tried to run their app on visionOS on the simulator? Okay, we've got a few people. Awesome. So how to bring React Native to visionOS? So in order to visualize this, I've used some Lego bricks. So first Lego brick is to fork React Native. Then we need to fix the build infrastructure for libraries to even link properly. Then we can adjust the source code. We can then bring native platform features. And finally, release. So all of this seems pretty simple, right? So let's go. The first step was to create a fork. So we went ahead to the React Native repository and clicked the fork button, and that's how React Native visionOS was born. Next, we opened the Aaron Tester app, which is an internal testing application for React Native, selected visionOS as the target, and clicked the Run button. And Xcode is working hard on building our app. And oops, we got tons of issues. So let's take a closer look on why we got them in the first place. So APIs that were deprecated before iOS 15 are unavailable on visionOS. So we needed to migrate them to their newer counterparts. And on top of that, some APIs don't really make sense. So let's take UI screen as an example. So here is a piece of Objective-C code that, don't worry, you don't need to understand, but it's using the UI screen main screen API to retrieve the size of the main screen so that we can properly initialize the React Native root view. And this is not possible to do on Apple Vision because we are actually looking at the main screen, so it doesn't make sense. And Apple Vision actually has two screens, one for each eye. So we needed to shift our focus from screens to windows floating in space. And visionOS puts our app by default in a shared space, so our app coexists next to others. So in order to properly initialize React Native in this scenario, we needed to retrieve the size of our main apps window. And on top of that, users can freely resize the windows, so that's something to keep in mind. So let's talk about React Native build parts and the ecosystem around it that we needed to adjust in order to make React Native work on Apple Vision. So we have the Android-specific part, iOS-specific part. We've got the shared layer, which contains some C++ and JavaScript. And there is also Hermes, a JavaScript engine optimized for React Native. And we mostly needed to adjust the iOS-specific part and Hermes. So before that, we needed to make sure that native build tools are working properly. So CocoaPods is a native dependency manager for iOS, and CMake is a build system that's used by Hermes. So thankfully, CocoaPods received an early on support thanks to Gabriel Donado from Expo. So let's take a closer look on how React Native uses CocoaPods. So React Native depends on many internal and external dependencies, which CocoaPods call them pods. And each of them has their own pod spec, which defines the platform support. So you can think of it like a package JSON. And CocoaPods is the key tool for properly linking and building React Native and its dependencies on iOS. So we also need to bring CMake in order to build Hermes. So at first, we disabled Hermes altogether, but after coming back to this a few months later, we discovered that CMake was actually passing a wrong flag. So it was an issue with the build tools, which resulted in it always building for the real device and not the simulator. And as I mentioned, we didn't have the real device, so it was an issue. And on top of that, what was confusing during the work on Hermes is that VisionOS had a code name XROS before, which Apple changed just before the release. So you never actually knew if you should call it XROS and VisionOS. So this proves the point that even Apple ships some legacy code on day one. But thanks to CMake maintainers, the issue is now resolved, and the pull request adding VisionOS support to Hermes is now merged. So next, we need to adjust the code base. So here's a piece of Objective-C code that fails to compile on VisionOS. It uses UN notification, which is just not available on this platform. And the quick and easy way was just to comment this part out. And that's what we've jokingly called comment-driven development. But after that, we obviously used a proper way of commenting out code using ifdefs. So the piece of code between those if statements won't be compiled for this platform. And obviously, in most cases, we need to implement a VisionOS compatible alternative, but in this case, it was fine. So after lots of hacky solutions, we finally got something on screen. And this shows a React Native app with a famous red box that's floating in the simulator kitchen. And everything looks a bit broken now, but that's what we'll fix next. So after we got a proof of concept working, it was time to clean things up for the initial release. So we started off by setting a solid foundation and bringing out-of-chip platform support to React Native Community CLI. So first of all, we added support to the init command. And thanks to this change, React Native VisionOS uses the same code as React Native init, so that you can initialize your React Native VisionOS application. And then we refactored CLI platform iOS to be CLI platform Apple in order to provide a reusable set of utilities that out-of-chip platforms can use to implement their own CLI commands. And by default, we get React Native run iOS, run Android. But if you want to have React Native run VisionOS, previously you would need to re-implement half of the CLI in your own out-of-chip platform. But thanks to this PR, creating CLI commands requires just a few lines of code, and we get React Native run VisionOS. So we wanted to make sure React Native VisionOS is as easy to adopt as possible. So we made sure that both old architecture and the new one, together with bridgeless, is supported. Although I highly recommend you to check out React Native VisionOS with the new architecture enabled, as that has been our main focus. And starting probably from React Native 0.76, this will be the default. So React Native has an API called platform, which allows us to retrieve the information about the platform we are running on. And the platform.os returns the current operating system. And at first we thought, okay, let's return VisionOS here. But unfortunately, this wasn't the best idea, as most of the code relied on actually having the iOS as the platform. So we needed to add a lot of additional code to make VisionOS work again. And platforms like React Native macOS and React Native Windows change platform.os to macOS and Windows respectively, but they are a bit different and not so closely coupled with iOS. So we decided to leave platform.os as iOS and look for a better idea. So we introduced platform.isVision that allows you to check if you are running on Apple Vision. So as I mentioned before, some APIs are unavailable on VisionOS. So we've upstreamed a bunch of fixes to React Native in order to make every core API work smoothly. And don't worry, these PRs are actually merged. This is how Meta merges PRs. So this is a good time to mention that during this effort, we've been focused on giving back to the community. We did that by contributing more web-compliant APIs, better iPad support, macOS, and tvOS support. We also did easier brownfield integrations for native iOS apps, and more. So now, let's talk about bringing VisionOS-specific features to React Native. So in order to click on something on Apple Vision, first we look at an element, and then do this pin gesture to confirm the tab. And thanks to React Native, just using the platform, we got gesture handling working basically for free. The only thing we need to keep in mind is that multi-finger gestures using more than 2 fingers won't work on Apple Vision because users only have 2 hands, so the gestures won't be translated. And regarding eye tracking, Apple doesn't expose any information where the user is looking because this is a potential privacy threat. But we can opt in to applying a hover effect when user looks at an element. This is how this hover effect looks. And this feature has been introduced to React Native Core, by the cursor pointer style. So you can apply it to any view, but you should mostly add it to views that are clickable. And this API is also available on iPad. So if you are running React Native Core 0.74, you can add cursor pointer to touchable elements, and users that are using a trackpad will get these nice hover effects. So we also introduced Window Manager API, which allows you to spawn and manage multiple windows in your app. And you can also pass and update data from your main window to the newly created one. And recently, we also added support to Ornaments API, which users can use to attach ornaments to their windows. And on top of that, we added the default ornament that you can see here, which allows you to trigger the dev menu when running in the dev mode. And XR API allows you to blend your content with real surroundings. So in order to open a new immersive space, which is a canvas that you can render into, so this allows you to open a new immersive space, which is a canvas that you can see here. So I will get back to rendering in immersive spaces in the next section. But for now, in order to enter into the immersive space, you can use xr.requestSession. And to close it, you can use xr.endSession. And we designed those APIs by the web spec. So after a few months of work, released the first version of VisionOS. On the very same day, Apple Vision was available to buy in the US. So we could start building using React Native on day one. So building things in the open is great, and the community got really involved in this project. So React Native heavily depends on community to augment core with features. So bringing new platform required us to migrate key libraries to VisionOS. Thankfully, most of the libraries got migrated by awesome community members. So thank you for that. So for the past few months, we've been traveling the world with Apple Vision and showcasing React Native running on VisionOS. And the reception was great. We get lots of wow moments and questions about the framework. So if you look closely, I got Mike and Eric wearing the headset here. Look how happy they are. So if you want to try it out, I have Apple Vision Pro in my backpack, and I'm happy to share it to you. So React Native Directory is a page that allows you to discover React Native community libraries. And it received VisionOS support, which enables easier discovery of community modules. Last but not least, I wanted to thank Microsoft for helping us with this effort and for bringing VisionOS support to React Native Test App, which makes VisionOS library development a lot easier. And going back to the story for a second, around end of May, we finally managed to get the device. And obviously, we couldn't just order it. It would be too easy. We had to fly to the US, buy the device, fly back, and then customs hold the device for 3 months in Poland. After waiting for 2 months, we decided, okay, they're not going to release the device. Let's get another 2 devices while being on a trip to the US. And somehow Michał Pieszchała managed to get them through the customs this time without any problems. So after 4 months from the release, we got the devices in Poland, and I was ready to work on them. So now let's talk about going beyond 2D rendering. So RealityKit is a framework from Apple that allows you to render 3D content. And combined with ARKit, it can be used to render inside of the immersive spaces that I mentioned before. And the demo that you will see in a moment uses this technology. And the primary language for writing with Swift is, the primary language of writing with for Reality Kit is Swift. But I would say that's one of the React Native superpowers, that you can always fall back to native code whenever you need to. And our primary focus for the past few months was allowing developers to render 3D content using JavaScript. And in order to achieve that, we've been working on bringing Babylon.js, that some of you might be already familiar with, to render natively using Metal on visionOS. So in order to achieve that, we used Babylon Native. And in the previous talk I gave, I showed this simulator screenshot saying that we are getting closer, only to uncover that when we boot the app for the actual device, we saw a black screen without nothing rendered. And this is the graph that shows how Babylon Native is built. We got the core, plugins, and polyfills. And we mostly needed to adjust the BGFX, which is a 3D rendering engine, to use the new Apple framework called Compositor Services. So together with Mariusz Pasiński from Callstack, we rewrote part of the Metal rendering pipeline in the BGFX library. And next up, it is something that I'm actively working on right now, which is the rewrite of the native XR plugin to support the new ARKit APIs from Apple, because for visionOS, they changed the whole API surface, so we cannot reuse any of the previous ARKit code. So I don't want to bore you with some low-level Metal rendering engine code, but why didn't the rendering work? So in short, the simulator of the compositor service that's used to compose views on Apple Vision is way more complex on the device than on the simulator. And simulator only shows the output for one eye, tricking you into believing that your code works perfectly, when in fact it doesn't work at all on the device. And funny thing is that after the first week of debugging, we got to render only to the left eye. So you could feel a bit like a pirate seeing only with your left eye. But then after the next week, we finally got it to render properly. And if you want to learn more, I wrote a pretty long tweet explaining this in detail. OK, so let's see it all in action. I've prepared a small demo app, which is open source, so you can check it out on my GitHub. So this is the application running on iOS. As you can see, it uses React navigation to render into the screen, to go into the screens. It uses a flat list to render the list of items. So now let's see how the very same app looks on visionOS. So we've got the same list of screens. We can go into the detail, but now for visionOS, we've added this additional button to preview this item in 3D. And as you can see, we have the 3D model of a chair that's spinning, and the spinning is actually done on the JS side using React Native Reanimated, and the gestures are done using React Native Gesture Handler. And when we enter into the immersive space, you can see a bunch of Callstack 3D models. And yeah, we can interact with the 3D space, and we can look around and change the spectrum of immersion of our immersive space. But I have one more thing to show you today, which is that React Native visionOS is just the beginning. We want to enable React developers to deploy their code to even more headsets and make React Native the best choice for building spatial apps. And more on this topic is coming next year, so if you want to help us, feel free to reach out. So you can start building for visionOS today and hopefully contribute some bug reports and fixes. You don't need the Apple Vision Pro, you can just use the simulator. So you can scan the QR code here. It will take you to the open source GitHub repo. Don't forget to leave a star there. So I also want to thank Michał Pieszchała for giving me a chance to work on this and supporting this project along the way, and also Matt, who is our technical guidance and poked us with the idea of actually bringing React Native to visionOS. All right, thank you.